Okay, so the next lesson is combining these transformations. Okay, so far, the first lesson for the pre-calc 12, we did some shifting or translations, and the second lesson was on stretching and flipping or reflections and stretches. Now, what we're going to do is we're actually going to combine um, all the transformations. Okay, so we're gonna reflect and stretch as well as shift. All right, so today, yeah, I got two examples, and through these examples, hopefully, you guys get a good understanding of this concept. Now, I need to warn you, you may have to watch this lesson a couple times. Not a big worry because it is, yeah, it's fairly new and fairly abstract. But so, anyways, let's get into it. So the first example here, we're given the graph of y equals f of x. So notice that we don't have an equation. We just have the graph of this function. And we want to sketch the graph of the transform function. And yes, it looks fairly complicated. All right, but I'm going to break this down step by step. All right, so the first step, so step one, let me just get this here. So step one is before, oops, where did that arrow come from? Oh, I think I could click. Okay. Let's try that again. Um, okay, sorry about that. Let's do that again. All right, so when we're doing these combined transformations, our first step, so step one, is to always factor out the number in front of x. Okay, so here what you'll see is you see inside the brackets, you see f of 2x minus 6. So before we start interpreting this transformation, what we need to do first is actually factor out that number outside the, or factor it out of this expression 2x minus 6. All right, so algebraically, it's going to look like this. We have y equals -3, and actually, yeah, so factor out the 2. So you're going to put, it's basically going to be a double brackets here. I'm going to factor out the 2, and inside the brackets here, I have x minus 3. Close the bracket, and then minus 1. Okay, so this first step is actually very important because if you don't, what you're going to do is you're going to get this shift wrong. Okay, the horizontal shift wrong. Okay, so we need to factor out the number in front of the x first. Okay, so once we've done that, next step, all right, so step 2, let's list off all the transformations. Okay, so list the transformations. Okay, so this will, yeah, the bad thing about you doing this on video is that I don't have I don't have that much space to write this all out, but I'll do the best I can. Okay, so again, this was the original question, but our first step is to factor out. So we're basically going to focus on this version of the transform function. Okay, so what I'm going to do now is, actually, I'll just erase this arrow here. I'm going to list off or number off the transformations we see. Okay, so there's a negative sign out front here. There's also this 3. There's this 2. There's the x minus 3. And then there's the minus 1 on the outside. So we actually have 5 transformations that are happening to this one function or this one graph. Okay, so for the first one there, use the link again. All right, so number 1, we have a negative sign in front of the whole thing. So the first transformation there is a reflection over the x-axis. All right, so, but in order to reflect the graph over the x-axis, what we're going to do is we're going to change the sign of your y variable. So I'm just going to write change the sign of y. Okay, so yeah, it is a reflection over this x-axis, right? But in order for that to reflect, what we need to do is we need to change the sign of our y value or y coordinate. Okay, so I just wrote change the sign of y. Next up, The 3 here is a vertical expansion by a factor of 3. I'm just going to write by 3. And basically what you're going to do is you're going to multiply the y coordinate by 3. Okay, so yeah. So the 3 out in front means that there's a vertical expansion by 3. Okay, the next one is the 2 on the inside of the brackets. So remember with the x's, it's actually the reciprocal that happens. So this is going to be a horizontal compression by 1/2. Okay, so when it comes to the x, or the numbers inside the bracket, so the f of whatever, you're always multiplying by the reciprocal of that number. Okay, so not the number itself. So this is a very common mistake, is to think that the 2 here means a horizontal expansion, but in reality, it is actually a horizontal compression. Okay, so it's 1/2. Okay, so what that means is I'm still going to multiply x this time by 1/2. All right. Now, what else do we have here? So next up, so the fourth one here, x minus 3. So remember that's shifting it right 3. And then the fifth one there would be down 1. Okay, so when we look at this new function, or the transformations from the equation, right, we can just break this down or list off the 5 different ones. All right. Now, the key thing with combined transformations as well, as a rule, is that we are always going to do, so as a rule, let me just, okay. So as a rule, so this is an important rule, is you're going to do reflections and stretches. Then you're going to do your shifts or translations. Okay, so always reflections and stretches first, and then your shifts or your translations. Okay. Yeah, so maybe in brackets here I'll write shifts. Okay, so we got a bunch of things going on in this example. Unfortunately, I don't have that much space to work with, but I have a feeling I'm just going to keep scrolling up and down. But hopefully we can follow. Okay, so again, just to review what we've done so far. First step here is always factor out the number in front of the x. Okay, so pull out that 2, so that becomes x minus 3 in the brackets. Once you get this version of it, you're going to list off all your transformations. And then, as a rule, we need to do the reflection stretches first, and then the shifts. Okay. Now, the other thing is, since we have 5 transformations going on, I did introduce the mapping notation in the other lesson, the previous lesson. And when it comes to combined transformations, where there's a whole bunch of transformations happening to one function, this mapping notation actually it comes in very handy. All right. So I'm just going to scroll down here. And actually, I want to keep number 1 up there. So again, just so that I can see the transformations, and we're going to write the mapping notation. Okay, so the mapping notation is kind of like a rule that we followed. We're going to plug in the points on the original function, and then once we plug it in, it should give us points that are on the new function. All right, so mapping notation, x, y. Okay, so these are the original points. What we're going to do is just going to write kind of like the algebraic steps that we would take in order to get the new points, or the points on the new function. Okay, so first one here, reflection over the x-axis. That's going to change the sign of the y coordinate, y variable. All right, so when it comes to the y, so that's the second one here, I got to change the sign. So it's going to be negative there, and multiplying it also by 3. So negative 3y. If I wrote that, that would take care of the first 2. Okay. Now number 3, this third one here has to do with, or applies to the x coordinate. Okay, so I'm going to multiply the x by 1/2. So in other words, I'm going to go x times 1/2. So in other words, x over 2. Right. So remember, multiplying by a half is the same as dividing by 2. I'm just going to write this as x over 2. And then move it right 3. So if I want to take a point and move it right 3, I'm going to add 3 to the coordinate. And then move it down 1. So to the y, I'm going to move it down 1. Okay, so hopefully that makes sense. This is the mapping notation for this example. All right, so if I take an original point, I'm going to do this stuff. I'm going to take the x coordinate, divide by 2, and add 3. And then for the y coordinate, I'm going to multiply it by -3 and subtract 1. Okay. All right, so to get the new points, so maybe I'll do it in red here. What I want to do now is just list off points that are on the original function here. So a here is at -10, +2. Point B there is at -6, +2. C would be at -4, -2. And D is at 2, 0. Okay. So these are the 4 points on the original function, right? Y equals f of x, so they would apply to this part of the mapping notation. And then what I want to do is I want to plug these ones in, and it should give us the points that are on the new function. All right. So for example, let's figure out what a prime is. All right. So what color shall we use? Let's go with green. Okay. So a prime, which is the new point. Basically, what I need to do, I'll just toggle between the red, is that I'm going to plug in -10 there into the mapping notation for x, and then divide that by 2, then +3, and then on the other one there, -3. I'm going to sub in +2 for the y, and then -1. Okay, so all I did there was I took this point A, which was on the original, subbed it into the mapping notation, get this, and now I can work this out. So I'll just switch over to green. So this is equal to, and I'll call it a prime again. So -10 divided by 2 is -5. -5 plus 3 is -2. And for the y coordinate, -3 times 2 is -6. -6 minus 1 is -7. All right. All right. So using the mapping notation, point A, which used to be -10, 2, now becomes a prime, which is -2, -7. All right. And we're going to do that with the other 3 points. Now this one here, yeah. So these ones here, I'm just going to do fairly quickly, all in one color, just to work this out quickly. I know the writing here is not the best, but hopefully you can read it. Okay, so B prime is going to become, what's that? -3 divided by 2 is -6 divided by 2 is -3. -3 plus 3 is 0. And then here I should get the same number, -7. Okay, C prime, what do we got here? -4 over 2 plus 3. And -3 times -2 minus 1. So C prime is, what's that? -2 plus 1 is, -2 plus 3, which is +1. +6 minus 1 is +5. Okay, and the last one there, D prime becomes 2 over 2 plus 3, -3 times 0 minus 1. All right, so D prime is 1. So 2 divided by 2 is 1. 1 plus 3 is 4. And we got 0 minus 1, which is -1. Okay, so these are the points that are on, and actually, you know what? I'll just call it y equals g of x. All right, so on the converted function for these points here. All right, so if I go back, I'm going to try to scroll back here and plot these points. So -2, -7. -2, -7 is right here. So this is now A prime. B prime is 0, -7. Right there. And then we have 1, 5. 1, 5, which is way up there. Okay, so that's C prime. And then the last one there is 4, -1. So 4, -1, which is right there. So that's D prime. Okay, so as well, I'm just going to connect up the points here. So A to B, well, this will be interesting. B, I got to write this up all the way to C. So I'm going to do my best freehand. Yeah, that wasn't too bad. And then from C to D. All right. So in green is the transformed function. All right. So yeah, so multiple steps. Totally recommend doing mapping notation to get your new points, and then sub in the old points, and the mapping notation should give you the new points. All right. Now the other thing is, yeah, if we just kind of look at the original function and just kind of go step by step, we can just see exactly what's going to happen. So this thing here, the original function gets flipped. So this first step is to flip it over the x-axis. So A to B actually gets flipped, so it's down in the negative here, and then it's going to go up and across like that. Okay, so that's just after the first step, and then vertical expansion, so it gets stretched skinnier, and then compressed horizontally, and then shifted right 3 and up down 1. Okay, so yeah, it's not really the best, I guess the best, I guess on screen here in the videos. It's not the easiest way to see step by step what's happening. It's a little easier on the whiteboard in the class. But anyways, the green one here, yeah, the green one here is now this red function with all of these transformations applied to it. All right, cool. All right, so that's the first type of thing that we need to kind of get a handle on is just going from one function to the graph of the other one. Okay, cool. So, and yes, if this is really if it is confusing to you, don't get worried, don't get stressed or anything, because we're actually going to spend 2 days on this stuff. In terms of the course, this combined transformations is probably the most important lesson in the whole course, because these transformations keep showing up throughout the course in the later units as well. Okay, so we need to really get a handle on this stuff. And again, this is the first time you're seeing this, so it's natural to be a little bit confused and so on. So we will spend quite a bit of time hammering this stuff into you. All right, so cool. All right, so that's the first kind of concept thing that we need to be able to do. Now the other one is going in the other direction. So in other words, given the original function, and then given the transform function, we're going to actually come up with the equation. Okay, so given one graph and then given the other graph, what happened in order to get from f of x to g of x. Okay, now this question here I actually took out of the textbook because, well, to be honest with you, my drawing skills, as you can see over here, if I was to make up an equation, probably not the best. So, so anyways, you'll find that this this question itself is in the textbook in the homework there. So, but I do actually every time I teach this course, I end up answering this question in front of the class. So I figure I might as well just stick it into the notes or into the lesson. Okay, so what's happening here is the graph of y equals g of x. So the red one here represents a transformation of the graph of y equals f of x. Okay, so this is the blue one here is the original, and then it's been transformed, and then this is the red one here is the new graph. Okay, so what we want to do is we want to determine the equation of g of x in the form y equals. All right, so anyways, we want to write it as an equation. Okay, so what you want to do here as your first step is to figure out which points on the original function correspond to points that are on the transformed function. All right, so to start off with here, I'm just going to label this one A, B, C, and D. Okay, so what we want to do is label on the green function, or sorry, on the g of x, the red function, we want to label the corresponding points or the transformed points. All right, so where does these points go? Now this one here is a little bit of a tricky one, all right, because you may think that the A gets mapped to here, but what you'll notice here is that this line segment here, if you can follow the cursor, is shorter than this line segment here. Now, if we look at our original function, this is actually the longer of the two segments. Therefore, In other words, point A is actually right here, gets transformed to there, okay, because this is the longer side. And so this would be B prime, this would be C prime, this would be D prime. So there's actually a reflection, okay, that you need to notice. And the way we, again, the way that we figure that out is that this A to B is the longer of the two end line segments, right? So on the new one, it's got to be the longer one as well. So that means if this is the endpoint A, then this is the corresponding A prime. Okay, so hopefully that makes sense. All right, so now what I'm going to do here is I'm going to actually just list off the transformations that actually we can see. Okay, so first thing I want to do is I want to actually see if there's any reflections. And you can see that, yes, there is one. Okay, so this original function, right, must have been flipped this way in order for, from A to B, it looks like it goes down in the original, but on the new one, it goes up, right? So A to B. So there is a definite reflection this way. So reflect, the first one here, I'm just going to write reflect over the x-axis. All right. Now, the other thing too is that on the original function, A goes from left to right. However, on the new one here, you can see goes that A goes from right to left in order to get to D. So in this case, there's actually two reflections. Okay, so we're going to reflect over the x-axis, but we are also going to reflect it over the y-axis as well. Okay, so there are two reflections that occur. Okay, so hopefully that makes sense. Okay, so this blue function has been flipped up and then flipped to the left. All right, so flip twice. Reflect over the x-axis, reflect over the y-axis. Next up, are there any vertical expansions or compressions? All right, now to figure out the expansions or compressions, what I'm going to do here is actually count. So let me just erase this part here and just pull out a different, I can use green, I guess. I want to count how high this thing actually is. Okay, so how many units? Right. So you can count the individual squares, or you can just say, okay, this high point is 4, this low point is -6. So that is going to be a distance of 10. Okay. Whereas over here, that's the high point, and here's the low point. It goes from 10 to 5. So this is a vertical distance of 5. Okay, so in order to get from, again, f of x to g of x, from blue to red, notice that there is a vertical compression. Let's use red here. So there is a vertical compression by a factor of 1/2. Okay, so it's been compressed vertically. And then next up, is there a horizontal expansion or compression? All right, so on the original, point A is right. Oops, scroll this down a little. Point A goes from here to D, which is there. Okay, so that is a distance of, what's that, -4 to +8. So that's a distance of 12. Whereas on the new function, from here to there, that is the distance of, let's see, -2 to -8. So that's a distance of 6. All right, so it should be 6 units. Yeah. So there's also a horizontal compression. By 1/2. All right. Okay, so hopefully this is kind of making sense. Now, this is where actually with these questions, this is where the kind of like a common mistake occurs, where the actual shifts. So to figure out what the shifts are, use purple. You are not going to actually count here to here. The reason you can't count it is because we need to actually apply these transformations to like a point on the original, which will actually move point A somewhere else on the grid. And then from there, that's where we count the shifts. Okay, so you can't count the shifts right now. Okay, so we can't just say right 2 and up 4. The reason we can't do that right now is because these transformations, which we always apply first, will actually change point A in itself. All right, so hopefully that makes sense. So to figure out what the shifts are, we actually need to take a point on the original function and apply these transformations, and then figure out what that point is, and then count from there. I know, maybe a little bit confusing right now, but let's just try it. Let's just walk through it. All right. So to find, actually, I'll write that out as a note. All right. So to find the shifts, or the translations, I'll use the word shifts. We must first apply the reflections and stretches, to a point on the original function. Okay, and so that will give us like an intermediate point, or yeah, so I don't want to use the word midpoint, but that will give us a kind of like a third point for A, and then from there, that's where we count our shifts. Okay, so so for example here, yeah, it doesn't matter. You can use A, B, C, or D, but what I'm going to do here is just use point A. So point A on the original function is at -4, +2. And then what I'm going to do here is apply these transformations that we listed, the reflections, to this point. Okay, so if I reflect it over the x-axis and reflect it over the y-axis, this will change the sign of both x and y. Okay, so I'm not going to write out the mapping notation or anything like that. I'm just going to kind of just work this out here. So basically, the first two here, reflecting over the x-axis, reflecting over the y-axis, basically changes the signs of your x and your y. Okay, so those are your two reflections. All right, so I change the sign of x from -4 to +4, change the sign of y from +2 to -2. All right, and then I also need to apply the vertical compression by half and the horizontal compression by half. So in other words, I'm going to multiply each one of these by 1/2, or in other words, divide by 2. So this becomes 2 and -1. Okay, so I'm going to call this this point here, let's just call it A double prime. Okay, so it's kind of like an intermediate step or intermediate point that we need to use, or we need to find to figure out what the shifts are. Okay, so in purple here, 2, -1. 2, -1 is like actually right there. Okay, so this is A double prime. So we're going to count the shifts from A double prime to get to the new point A prime. Okay, so from here you'll notice that I'm running out of colors. What should I use here? Let's go orange. Okay, so from here I need to go up this distance and then left this distance to get to the new one, or to get to the final point for A prime. All right, so that is we're going to go up 7 and left 4. Okay, so to get from A double prime to A prime, we need to go up 7 and left 4. Okay, so again, you're not going to count the shifts from the original A. You're not going to go right 2 and up 4. You need to actually apply the transformations or the reflections and stretches to point A. That'll get you to this point here. And then from here, you're going to count up 7 and left 4. Okay, cool. So these are the other, you can number them off as 5 and 6. So these are the other transformations. So if I want to summarize all of this, all 6 of these transformations, and write it into equation. So if I want to summarize it into an equation, I'm going to write g of x is equal to, all right, so what's happening here? So we have reflections on both, so it's a negative out in front. Vertical compression by half, so that's 1/2 f of, all right, and there's also a reflection over the y-axis, so there's a negative sign in here. Horizontal compression by 1/2. Okay, so remember for the x, though, it's the reciprocal that needs to be written in here. So instead of 1/2, it should be 2. And then I'm going to have bracket. It's up 7. Okay, so left 4, so that's going to be x plus 4. Close the bracket. And then up 7, so that's plus 7. All right, so let's try that again. So plus 7. All right, so this would be the final answer. Yes, a lot of things happening right here going on. So, so when you're going from the original, given the graph of the original to the final, and trying to find the equation, you need to do, again, the reflections and stretches first, apply it to a specific point, get the intermediate point, and then from there you can count your shifts. Yeah, so if I used, like, instead of using point A, which was negative 4, 2, if I used point C, which was like 4, 4, did the same things, you'll see that the shifts are still the same. You'd have, wherever C double prime is, you'd still have to go up 7 and left 4 to get to the new point. All right, cool. So yeah, so this section here is very important, this lesson. And again, we're going to spend a couple of days on this. So what you want to do here is work through the textbook questions for today, and then what I'm going to do is I'm going to post a worksheet from further practice. All right, so we're going to spend 2 days on this, and hopefully it makes sense. But again, if it doesn't, as you work through it, you're still confused, don't stress out or anything. Just let me know, and I'll do the best I can to help you out and maybe answer any questions that you might have. All right, cool, guys. So that's it. That's that. Have a good one. Cheers.